Hello there, my name is Boatin Rabi and I'll be taking you through atomic heat and optics. Unit 1, Geometrical Optics. We will first take the first session, that's reflection at plane surfaces. Let's look at the objectives of this section. The first objective is to be able to recognize incident rays and reflected rays, and also recognize the angle of incidence and angle of reflection, and also explain how images are formed by plane mirrors. Also solve problems related to reflection at plane surfaces. And lastly, state the laws of reflection. Light, as electromagnetic radiation, is made up of very discrete particles that we call the photons. And yes, we all know that light travels in a very straight line. So, in presenting the path of light, we draw a thin line with a narrow head on it, as presented in figure A. The narrow head presents the direction of propagation of light, and that is called what? The ray, as presented in figure A. A group of these rays give rise to what we call a beam, as presented in B, C, and D figures. And also, the beam can be parallel beam, as presented in B, convergent beam, as presented in D, and also divergent beam, as presented in C. Going on, properties of light are quite a lot. The one we'll be dealing here is reflection. Light rays can be reflected on a plane or curved surface depending on the nature of the surface. From our old definition of reflection, as the bouncing back of light rays when it hits a smooth surface. We will use this schematic diagram to explain. Let me use a laser pointer here. Great. So we have an incident ray here, a reflected ray here, and a normal. This normal is always perpendicular, that is 90 degrees, to our plane surface here. And always, the incident ray here makes an angle, which we call the angle of incidence, and it's always to the normal here. Also, the reflected ray also makes an angle that we call the angle of reflection, and it's always to the normal. These angles here are always equal. Supposingly that we have the angle of incidence to be 50 degrees, it means the angle of reflection has to be also what? 50 degrees. Supposingly that we have the angle of reflection to be 90 degrees, what will be the angle of incidence? So let's look at the laws that we get from the laws from reflection. 1. The incident ray, this particular ray, the reflected ray, and the normal at the point of this normal at the point of incidence all lies on the same plane. And the second law states the angle of incidence, that is our eye, is always equal to what? The angle of reflection. Types of reflection. There are two types of reflection. That is the specular reflection or regular reflection, and the diffuse reflection or irregular reflection. For the specular reflection, it happens when you have a very smooth plane surface, unlike the diffuse reflection where we don't have a very smooth enough surface. Now, let's move away from rays and beams and focus on objects. If the mirror is flat or plane, the image of the object appears to lie behind the mirror at a distance that is equal to the distance between the object and the surface of the mirror, as we can see here. So here we have the object here, and we have the observer here, and our image here is formed behind the plane mirror. And these are some of the properties that we can observe here. That is, the image is what obtained here is what is virtual, and I'll explain that in a subsequent slides. And the image here is literally what? Inverted. And when you say a literal inversion, it's when we have our right here to represent a left and a left to represent the right. So in case you're in front of a mirror, your right, when you raise your right hand in the mirror, it's not your right hand that you're seeing. It's going to be literally inverted. Meaning, you raise your right hand in the mirror, it's going to be supposedly like the left. The image too is what? Is erect. When you say it's erect, it stands like this. So it's two ways. It's either erect or inverted. But our mirror, plane mirrors, forms an erect image. And always, the image that we get from a plane mirror is always the same size as the image. Supposedly, in case my size is this and I stand in front of a plane mirror, I'm not going to get a big size like this. It's the same size I'm going to get. And lastly, the distance between the image obtained from the mirror is the same as the distance between the object from the mirror. So these are the characteristics that has already been explained. Let's look at the types of images that can be formed. And these are the real image or the virtual image. And a real image is one formed through the actual intersection of light rays and can be captured on a screen like the ones that we normally see, telejeters and others. On the other hand, virtual images are formed due to the imaginary what? Intersection of light rays. So virtual images cannot be seen on a screen and are not what? Photographic plates. So a rare image can be formed on a screen, and one property is inverted with respect to the what? To the object, and formed in front of the what? Of a screen. Unlike the virtual image, it cannot be formed on the screen, and thus is formed what? Behind a screen. It's always erect with respect to the what? To the object. I hope you enjoyed this section.